Okay, since 1:15 is just within 1 minute, so at the end, I would like to remind you that if you would like to obtain the certificate, on the chat, we will have the link for giving your data, and then we will provide any people who would love to have such a confirmation that you are attending on the Didactic Friday. You can have such a certificate, but just fill the information on the link that will be provided soon. And I think we could slowly start. What do you think, ladies?
Yeah.
Are you ready? Okay.
Ready.
So, welcome everyone on our next edition of Didactic Friday. Today we are going to talk about how to use Socrative and AI to reinforce threshold concept. And this subject was prepared by two professors, Maria José Canet and Maria Asunción Pérez-Pascual, right? From the Politècnica University of Valencia. And probably I will have many questions at the end, so I will write them down and ask them at the end. So ladies, professors, the floor is yours.
Thank you for the presentation. My name is Maria José and she is Asun. So we divided the presentation in these 6 points. We'll start with an initial discussion, talking about why our students don't understand us. Then we'll move to the theoretical framework of the threshold concepts. And after that, we talk about the threshold concept we've been working on during the last years, the Ohm's law. After that, Asun will continue talking about how to use artificial intelligence for Socratic tutoring and explaining our experience with the Ohm's law. And finally, we draw some conclusions. Let's start thinking about why our students don't understand us, and this is very frustrating. So the first thing we need to think about is if they are trying to understand us or if they are not. We have some students that don't try. Some of them don't try because they feel overloaded. They have lots of subjects, lots of tasks, and this is a problem of self-regulation. On the other hand, there are other students that don't perceive that it's important to understand to pass. If we ask the same information we give them in the classroom, they just repeat. Repeating is enough to pass. So we can change that very easily. It's just to change our teaching approach, just reconsider the assessment. But we have students that are trying to understand, but they cannot understand us. Some of them have some deficiencies. Perhaps the concept of the problem has a very high cognitive load and they are not able to manage that. Or we as experts have some mental representations that students are not able to do them. Or even we can see the complete picture, the overall view of a problem, of a subject, but they are not able yet. And there is another group. There are concepts that hinder their understanding. They are concepts that are very, very difficult and very, very special and key concepts of the disciplines that are difficult to understand. And if you don't understand them, you cannot get into the subject. These are what we call the threshold concepts. Let's think a little bit more about our students. I'm sure you can distinguish several types of students in your classroom. We have some students, I have a lot of these ones, that are oriented towards reproduction. They just want to know what they need to study, and they just repeat what we explain in the classroom. sometimes even you change the exam and they repeat exactly what you said in the classroom, and it's not the answer of what you are asking them. These are the surface processing students. They feel stressed because they don't have time to memorize everything, and they are dissatisfied. Also, is not motivating that type of learning, but it's less time consuming, that understanding. On the other hand, we have a few students that are oriented towards meaning. They need to understand every single sentence you say in the classroom. They ask continuously, why? If not, always asking everything. And these are deep processing. They need to understand to continue. And when they understand, they are really satisfied. You can see the smile in their face. But that needs more time. If I ask you how many students do you have in your classroom, I'm sure I have two. I have in the first line in my classroom 2 students, not more. And then there is a lot of students that only tries to survive. They only want to know what they need to do to pass the exams. These are the oriented toward marks students. So what's the idea? The idea is to use the artificial intelligence to move these students oriented towards reproduction and these students oriented toward marks to approach them to the oriented towards meaning students. Move them from one perspective to the other and help them to understand us. So, can we foster this deep learning of our students? The key point is putting a distance between what we give in the classroom, what we explain, and then what we ask in the exams. If we ask exactly the same as we give, they know that repeating is enough. But if we put some distance, we make them think. And if we make them think, we make them understand. But we need to train them. We need to make them think in every single lesson. We cannot do it only at the exam because it's not going to work. Okay? So what's the idea? The idea is to move students from the novice way of thinking that only know techniques or protocols to the expert way of thinking, of reasoning, who have a deep understanding of the core concepts. And this can be achieved with this distance. But here we have some key questions to reflect on. And very difficult questions to answer even for us as experts. What does it mean to understand our subject? Or which type of resources can I use to facilitate this understanding? Here, the artificial intelligence can help us a lot. Or even how can we explain our subject to avoid the alternative conceptions of our students? These alternative conceptions, we'll see it later, but are naive ideas that students have even before instruction, before coming to our class. And they build their knowledge upon these naive ideas. So here, key point will be to promote the qualitative reasoning versus the quantitative reasoning. We are both professors at engineering. So our students have lots of problems with math. And many times we focus on the math resolution. But this is not a good idea because if we not analyze the problems qualitatively, students only repeat procedures, mathematical procedures, but they are not understanding these concepts, these problems. So let's move to see what's a threshold concept. This term was proposed for Meyer and Land in 2003. And they say that is akin to a portal, opening up a new and previously inaccessible way of thinking about something. We relate that with in the classroom when you are teaching and you have a concept that you know that is problematic, and you explain it, and you feel it, that your students are not understanding because you feel it with their faces. They don't understand it. And you repeat it, and the concept appears again and again, and you try to make them understand. And at some point, you can see the light in their eyes, like the happiness in their face is like a click. No, they make the click, and they understood you, and it's very satisfying for them and for you. So this is like crossing that portal. Every single discipline has three core concepts, and there is a lot of literature related to this. Some characteristics. There are central ideas of any discipline so ingrained that the expert has incorporated into their way of thinking, are the expert glasses. Many times we cannot understand why our students don't understand us, because it's so easy for us, because we think with that concept. So we need to research a little bit about where students have the problems related to these concepts, and talk a lot with them to identify what's the problem, because we cannot see it. It's so easy for us. These are core concepts, very important concepts that students need to understand and put into practice to become experts, to think like as an expert. So it's necessary for them to understand them. Unfortunately, they are often troublesome, very difficult, counterintuitive ideas that can hide the learning process, and is not a linear process. You think that they understand, but they don't. They come and go. It's like it's not linear. There are alternative conceptions that are very, very persistent, because they have it, as we are our expert classes put on, they have their own alternative conceptions put on their minds and always come out. So it's a process. It's something that needs to mature. It needs time. It's not a lesson. It's not a single lesson. It's not a 2 weeks lessons. It's something that needs to be worked on in all the semester, and even in several semesters, in several subjects. But I'm sure that you are thinking that you don't have time to work on physical concepts in your subjects, because you have a curriculum, you have to teach what it's put in the curriculum. That's not true, because we do it, so you can do it. It's, for example, I teach electronic devices, which I need the this threshold concept, the Ohm's law, but I don't explain it in that subject. But it appears in every single lesson, so I work on it. And when the students cross that threshold understanding, the learning is exponential. You cannot imagine how satisfying it is working with the students and watch how they are understanding you and advancing in the deep understanding of your discipline. So you can do it. More characteristics. A threshold concept is always transformative. It causes a significant change in the perception of a subject. I told you that they seem to understand it, but they don't come to the initial state. If you, for example, in the classroom, I only need to, when they reason improperly, reason with this, managing correctly this threshold concept, at the end of the term, if I say, are you sure? Only that, they reason properly. At the beginning of the course, if I say, are you sure? Just yes, because that or this. Okay, so it works, but little by little. if that way is irreversible, they never go to the starting point. It's like they put on the glasses. It's not an expert. It's like going to an expert and they don't put the glasses off. The three core concepts are integrative. They are related to many key concepts of the same disciplines. So if you understand the three core concepts, it means that you understand the links with the other concepts related in the discipline. They integrate. Of course, they are troublesome. They can be difficult to understand at the beginning, and we need to accompany students in the process. And they are called also liminal, because they are in the transition between the two ways of reasoning, the novice and the expert way of reasoning. Let's talk a little bit more about the alternative conceptions, because are very related to the three core concepts. Is that if it's a difficult concept, students tend to simplify it in a non-scientific way. So they have like naive ideas about this complex concept, and upon these naive ideas, they build the new knowledge we transmit in the classroom. So if the base is not correct, the building will fall down. It's not meaningful what they are learning in our lessons. So it's really important to identify the alternative conceptions of our students and help them to overcome them, to unroot them, work in the classroom with these alternative conceptions. In this way, we will build this appropriate scaffolding to incorporate the new knowledge, and the students will be able to deeply understand this threshold concept. Okay, this is the theoretical framework. Let's move to a the practical application. Okay, we work from the academic year 2020-2021 with the three core concept of Ohm's law. And you will think, but Ohm's law is very easy because it's just voltage equal to current multiplied by resistance, and that's all. It's just three variables in an equation. What's the problem? It's a very big problem. Why we started to work on that concept? Because although our students passed the exams, we identified a lot of conceptual problems with this law, not only in first-year students, but even in fourth-year students. Even when they finished the degree, they still had problems with this law. So we wanted to work on that. So we designed a classroom intervention in 2 degrees. The first one is the degree in interactive technologies, and we had in this degree 1 subject, basic electronics, in which we explained the circuit theory, and we applied this circuit theory to some electronic devices. And we also did the same intervention in the degree in telecommunications. In this degree, we have more time to explain electronics, 2 subjects. In the first semester, we explained the circuit theory, and then in the second semester, we applied this circuit theory to electronic devices. So the first thing we work on is to try to answer the question, is Ohm's law a three core concept? So we intuitively, we think that it was, because all the theory, the Kirchhoff's, Mesh's laws, all the circuit theory depends on Ohm's law. If you know Ohm's law, you can derive all the other laws. But we went to the literature and we found multiple references that identify Ohm's law as a three core concept. And also we found numerous studies on misconceptions or alternative conceptions related to this law from the early 80s. And students still have the same problems, exactly the same problems. So we proposed the following research questions. What reasons prevent students from understanding Ohm's law? We concluded that some of the alternative conceptions were really persistent. Another question, are there alternative conceptions related to Ohm's law in my class that are not identified in the literature? We found one extra alternative conception related to the concept of power. And then we wanted to know if the classroom's dynamic that we propose in the research improve the understanding of Ohm's law, if transform the students' prior conception, and if the students retain this new conception. So to answer all these questions, we designed this information. First of all, we did a deep literature review, looking for alternative conceptions. We summarize all what we found in the literature in 15 alternative conceptions and one that we detected in the qualitative analysis of our research. And then we also look for best practices to avoid the alternative conceptions that are summarized in here, include activities with reflection and discussion, promote the qualitative versus quantitative analysis, the use of simulators, no use of metaphors, and use real examples. All these best practices were put into practice in the classroom's dynamics that we propose in both groups. And then we also needed to measure the understanding of this concept. And to measure the understanding, we look for conceptual tests. We found two, and we decided to use the direct test because it was previously used at university level. This test is composed of 29 multiple choice questions, most of them related to some alternative conception. So the conceptual tests are designed to identify problems of the students, alternative conceptions of the students. Okay, so we use this conceptual test direct as pre-test before instruction in both groups, as post-test after the first semester. We ask the reasoning because we needed to understand the reason of the selection of the answer of the multiple choice answer. We wanted to know how they were thinking. And we deliver again the test asking reasoning at the end of the second semester. So this second delivery was a post-test, another post-test in the telecommunications degree, because they had one complete year of electronics. But in the interactive technologies degrees, students had been 5 months without instruction in electronics. So it was to see if students retain this knowledge. Okay. Okay, all this information, we have it on our LMS. So we extracted like 4 enormous Excel files with all the reasonings for each of the 29 questions of the test, each student reasoning for these 4 Excel with hundreds of reasonings. Asun and I independently analyzed all this information, trying to assign at each reasoning some of the alternative conceptions we identify in the literature that we have here. I'm not going to explain it to you, but we know it. which alternative conception were in the classroom. So we had, imagine, like 80 reasonings that show that the students have the alternative conception too, or more than 70 reasonings that show that the students have the alternative conception 7. Okay, we have lots and lots of evidences. With all these evidences, we thought we don't want to expend, because we spent hours and hours and hours and hours trying to analyze all the reasonings of the students. So we thought that not anymore, we don't want to do it. So we thought that artificial intelligence could help us with that. And in fact, now it's helping us with that. Okay, but here we have lots of information about how novice students reason. But not only that, because with comparing the way that students reason, we were able to construct this conceptual map showing how we reason, how the expert reason. Here we have the Ohm's law and all the other concepts related with Ohm's law, and even the links between all these concepts. And we know which link causes each alternative conception. We have a lot of information from the expert point of view and from the student point of view. So all this information is what we are using to feed artificial intelligence to create the tutor, the Socratic tutor with artificial intelligence to help students to understand this concept. Okay, so now Asun will continue with the rest of the presentation. Okay, so at this point we have a lot of information about the way of reasoning of the expert, the alternative conceptions that the students have, and the way of reasoning of the naive of the students. So we thought, okay, maybe artificial intelligence can help us in both goals, to identify alternative conceptions and to tutoring our students in order to bring them to the expert way of thinking. We know that artificial intelligence allows us to personalize learning, to create a path of learning for each student in order to their needs. We think that it could be used to promote deep processing if we try to bring students to the way of thinking of the expert. It could encourage critical thinking because we are going to confront students with their alternative conceptions in order to overcome them. It could dismiss teaching workload if it is able to identify the alternative conceptions. It could do all the work that Maria José and me did when we analyze all the reasonings of the students. And it could increase student motivation and encourages their self-regulation because students are going to confront with their alternative conceptions. They will be aware of their mistakes and they will overcome these mistakes. And they can work with the tutor 24/7. So they have a tutor in their home. Okay, so let's go to see how we have do this. This is our project. We have been developing this project in 2 years. Members of the electronic department, with members of the communication department, and some of the personnel of the IT department in the university. Our project is based on a website. We have a website. And this website is connected to ChatGPT. This is the engine that we are using, and this is the best for us. But it's not. Maybe it's not the best for you. We talk about it. This website has some conceptual exercises that has been specifically designed to confront students with their alternative conceptions. So the design of this exercise is key. Students are going to try to solve these exercises, and when they have some problem, they can ask to the tutor, to the ChatGPT. But the tutor are not going to solve the exercise. It only is going to allow questions. It has to perform Socratic questions in order to confront the students with their mistakes and to bring them to the expert way of thinking. So our platform is going to do two things. On one side, it's going to tutoring our students. On the other side, it's going to identify their alternative conceptions. This is why it is helping us to continue with our research. This is the schedule of our project. At the first of the project, we have all the research study about the threshold concepts related to the Ohm's law, so we have a lot of work done. The first year, we designed the exercises, the conceptual exercises, and we test some artificial intelligence engines in order to see how they behave with these exercises. Then we adapt the context created with these exercises to fit the virtual tutor using the expert reasoning, and we create a web interface. When the interface was created and the context was done, we test with expert this interface, and now we start to testing the interface with the students. In this year, we are going to do a pre-test, a conceptual test at the beginning of the course. Then students will be able to work with the tutor, with the virtual tutor, and after at the end of the semester, they perform again the post-test in order to compare the initial performance and the final performance. So we are now here in this point. The key of the tutor, the key is the context. The context that we are developing in order to guide the behavior of the artificial intelligence. This context contains some points. For instance, it defines the task we want to perform, identify alternative conceptions, or tutoring the student. It defines the target users. This, in our case, the target users are students from the first year of engineering. It defines the conceptual framework, in our case, the Ohm's law. Specify how we want to interact with the artificial intelligence, and specify which documents can be used as a basis when interacting with the user. We don't want the system go to internet and grab anything it defines. No. We want that the tutoring was based on reliable documents. This is very, very important. So whatever interaction that you do with artificial intelligence, the context is key. It guides the generation of pertinent responses and enable a smoother and more effective interaction with the user. So in our case, our context is composed by two big documents. On one way, we have all the reasonings that we obtained from the test direct 1.2. All these reasonings that Maria José and me was studying and analyzing, all of this can be used to fit artificial intelligence. And this is perfect for identifying the alternative conceptions and other students have, because would be very, very, very common to these reasonings that we obtain from this test. On the other side, we have the expert reasoning, the way of reasoning of the expert. And the way of the expert fight against alternative conceptions. And this is used to create questions for Socratic tutoring. For instance, here you are a context for alternative conceptions identification. We said to the artificial intelligence, you are an electronics teacher who wants to identify alternative conceptions related to Ohm's law from the written reasonings of your students. Specifically, you want to identify this alternative conception, which is the sequential model. Below this alternative conception is described, so we have to describe exactly what is this alternative conceptions. We have to give examples of reasoning from some students who present these alternative conceptions, and we have to define the way of reasoning of an expert. And then we have a lot of examples, student reasoning, and expert thinking. This is the content that we use for alternative conceptions identification. On the other side, the context we use for Socratic tutoring is similar to this. You are an electronic teacher with the role of a Socratic tutor, an expert in alternative conception related to Ohm's law. As a Socratic tutor, remember that your responsibility is to guide the students to the correct answer by using questions. This is very important because if you don't say this, artificial intelligence goes to internet and tries to solve the problem, but we don't want that this solve the problem. We want that they guide to the students to the expert way of thinking. So we have to tell them, the artificial intelligence never give the answer. Never give the answer. Instead, you should ask questions to guide the students to the correct answer. And then we tell that use a patient, adaptable, and stimulating approach, etc. And this is the way that we test some of the engines of artificial intelligence. We give a problem statement, the answers of the students, the reasoning of the students, and then we tell artificial intelligence to give the solution of the problem, to explain why this is the solution, to identify alternative conception present in the student reasoning, explain why it is identifying this alternative conception, present questions to verify that this alternative conception is present or not, and present question for Socratic tutoring. This is all the things that we ask artificial intelligence to do. We have test all of this artificial intelligence using POE. POE is a tool that allows us to create a bot that is connected to one of the artificial intelligence that is actually in the market. So in our case, we test POE with ChatGPT, GPT-4, GPT-4 Turbo, Llama, Gemini, Claude, some of the engines that we have available in the market. Depending on your field of study, one of these engines are more suitable or less. No? In our case, ChatGPT Turbo is perfect. But maybe if you are working in software, making programs, Gemini is very good for it. And if you are working generating with creative text, writing text, maybe Claude is good for you. It depends on your field of study. This is an example of our results. This example is from ChatGPT. We have a problem. This is the problem in this circuit. If the resistance C increases, what happens to the brightness of bulbs A and B? This is a typical problem in electronic based on Ohm's law. This is from test direct. These are the possible solutions, and the correct one is that if resistance C increases, E and B decrease. This is the correct one. If a student says that the correct one is A remains the same and B decrease, it is because this student have alternative conception number 4. that is sequential model. So we feed our artificial intelligence ChatGPT with this problem and the responses of the students. So student 1 says that he chooses the first answer, A, and he chooses this answer because his reasoning is this one, because resistance C uses part of the energy that will be delivered to B. So we ask to the artificial intelligence that identify if this student have alternative conception number 4, and it identifies perfectly. We asked artificial intelligence that they give a reason for this identification, and he reasoned perfect. Things resistance C only affects B, ignoring the global series effect. It is perfect. And we asked artificial intelligence for a confirmation question and for a Socratic tutoring. And these questions are perfect, are the same questions that Maria José or I did to our students. These are the results with other engines. As you can see, ChatGPT is perfect for us, 100% of accuracy in identification and 100% in accuracy in reasoning. And the questions that it proposes for the tutorization are perfect. The rest of the engines, not so perfect. Some of them are very good identifying. For instance, Llama is very good identifying, but it doesn't reason so good than ChatGPT.
With ChatGPT Turbo, we feel clonating.
Yes.
The feeling is that it's me talking. Yes. It's me.
But this is in our case. So. Okay. Our website is implemented using Streamlit. It's very easy to program with this platform. It is connected with ChatGPT Turbo, but we can change the connection and use another artificial intelligence because it's only aligning the code. And we are saving all the students' interactions in order to analyze it and continue with our research. This is our website. I have traduced all the text because it's originally is in Spanish, so you can see it in English. This is the circuit. This is the possible answers, and we ask for reasoning. We need that the students tell us why is choosing one of these answers, and then here is a field in which a student can interact with the Socratic tutor, and this Socratic tutor is working with the instructions that we have given, without solving the circuit, only given questions in order to bring students to the expert way of thinking. And we hope, our expectation is that using this artificial intelligence tutor, we can transform a student's reasoning so that it approaches to the expert way of reasoning. We can personalize the above process without increasing the workload of teachers. That is very important. We are very we have an amount of workload, so we can help teachers to analyze the students' way of reasoning, and we can foster critical thinking in students and increase their motivation, and continue with our research about learning processes that we know that it's very important for all the subjects, for all the disciplines. Here you are some of the references that we have used in our work. You have our paper when we explained all the intervention that we did, and that's all. If you want you have some questions, we are available for it. Thank you very much.
Thank you very much. There are some cheers which you can see on the bottom of the slide. So Of course, if some of our audience do have any questions, feel free to raise your hand or just turn on your speaker. If you would like to ask some questions on the chat, I can, of course, translate them or read them out loud. But even though if there are no questions for now, I have some questions. So yeah, I made some notes. So the first question is regarding the AI. Do you think or do you feel that it might be problematic that the phenomenon of AI hallucinations might hinder the process, might damage your conclusions? Because as far as I understood, when using Socrative questions, the problem of hallucinating is like decreased. Is that so?
Yes, because we put the context, so big context with the way we want the artificial intelligence act, and with all the expert way of reasoning, and we explain it in that context that the tutoring questions they have to use our expert way of reasoning to extract that questions. So it's not going away, it's not going on the web to take that. There are no hallucinations by now, and we do hundreds of tests. No, because we limited the behavior of the artificial intelligence with the contents and with all the documents that we give to conduct the behavior.
This is key because if you let the artificial intelligence free, it goes to internet and it grabs everything, and there is a lot of mistakes there is a lot of alternative conceptions in internet. So we have to limit, we have to mark what are the documents that are used to tutoring the students.
In fact, artificial intelligence doesn't know anything about electronics. It has exactly the same problems as our students, and my students tell me that they are trying to use it to artificial intelligence, and that it cannot solve the problems I propose to it. Yeah, I know, we will solve it. Yeah, so it's key, it's crucial to fit with the expert's way of reasoning and to fit with the way you want to that artificial intelligence behave.
Okay. So again, we are exploring the fact that the prompt is very important here. Okay, thank you. That was perfect answer for that question. I wasn't realizing that. Thank you. But now we are having questions from Roman. Would you? Thank you.
Yes, hello. Nice to see you again. We've met in Valencia last year. I would like to ask you to tell a bit more about one point that was in your presentation, that you are against metaphors, which on the other hand might be very helpful with explaining some, some things to students, but you expressed very strictly no metaphors. Could you tell something more about it?
Literature is against metaphors. For example, in electronics, it's the water flow as the current flow. It doesn't work because when it's like if students see several resistors connected in a line, like the current would flow, but if the disposition of the circuit is not what they is the same in series, but you put it in another way, the flow would not be the same. There are some metaphors that promote alternative conceptions. Perhaps in other disciplines, there are some metaphors that simplify the understanding, but not promote alternative conceptions. I'm not sure about it, because they always simplify the concept. The key concept
is not simple.
Are not simple.
It's not simple.
Are not simple. Perhaps you can introduce them as a way to, it's like that, but it's not that, because you have to take into account this and that, and you know. But if you say it's like that, students grasp it's like that, and the rest of the information they dismiss it. So I would say that
It's dangerous. It's dangerous.
So these parallels might be misleading.
Yes.
Okay.
Mm-hmm.
Okay, thank you.
Thank you.
Yeah, thank you. Thank you, Roman, for that question. I would like to remind you and ask Natalia to put the link here at our event, at our chat, for people who would like to have the certificate at the end. And I have another question, if I may. Do you have some more time?
Yes.
Okay. Okay. Perfect. So another question would be also connected with the previously asked, previously talked thing. So you said that there were many students which were describing the reasoning, and my question is, how many students from all of your research made a statement or made a reason that they were just guessing, or that was the lucky guess, or they don't actually know that they think that this is the action, or maybe was that so that most of the students knew the answer, or at least thought they knew the answer?
We have a wide variety of students. Imagine we have even students that choose the correct answer, but the reasoning, they had two errors to get, yes, two alternative conceptions that both of them together make to select the correct answer. Other students that the reasoning was that you cannot get any information for that. And that's one of the reasons that we need the tutor, the Socratic tutor, because we will have more interaction with the students, not only written answers, several.
Are you thinking?
Yeah, several interactions, because was difficult, and some reasonings we need to interpret them, and both of us do it in the same way, but because we saw the same mistakes in the classroom every single time. But we need more information to understand how our students reason, because if we don't understand that, we cannot help them.
Okay, yeah, and you have those expert glasses. Okay, all right. I have another question regarding the whole concept. Somewhere previously you were talking about this naive idea. Was that concept connected with the thought that I have that feeling that I read it in some book, as far as I remember, which I received at ETH. Thinking, as a matter of fact, is simplifying the reality. Do you think that this naive concept, naive idea might be connected with the fact that just thinking is just simplifying?
Yes, of course. Yes, and many times the problems comes from the high school, because teachers simplify the complex concepts, trying to facilitate the understanding, and then come with this alternative conception, with these naive ideas. Now we are starting researching in high schools also to see where the problem is.
Okay, but isn't that connected with the time? Because we have some specific limits regarding every single step of education. And I have a feeling that this is a problem that teachers often do not have enough time, while AI might give them this additional power or time to interact with some students.
Yeah, we always having in mind the curriculum. We have this curriculum. We have to finish this curriculum. If students don't understand anything, the meaning of that. Perhaps it's better to focus on the key concepts of a discipline and make students understanding those concepts deeply. Because if not, if they don't understand one topic, one or many topics of one curriculum, it has no sense.
Okay.
But it's difficult to change. That is difficult. It's very difficult to change in our system, at least in the Spanish system. I don't know in the Polish system.
In the Polish it's quite the same. We struggle with very similar problems. Regarding this threshold concept, I also have an idea or a thought that I think it's very connected with the concept of knowledge anchoring. So the concept where you have already some informations and you are linking those information to another while forming the long chain of knowledge or informations that you might use. So is it why I have that thought? Is it the concept of the knowledge anchoring and the threshold? Is it connected with the fact that you mentioned that from the certain point of time, this knowledge gain is exponential because you have more information, you can learn quicker because you can catch many different points of this chain? Is it connected somehow?
Yes,
totally. Totally. This is why it's better to spend time in these concepts. And when students have a deep learning or a deep understanding of this concept, they are able to go up very, very fast.
Okay, so I have a feeling that this threshold concept is this magical moment which we teachers just love when you can see, okay, my student just, okay, now I understand.
Yes.
Probably that's the moment.
Is this the point? Is this?
Okay. So since you also mentioned that this is not a line, you also showed this, it might be tangled. Is it, am I understanding that correctly? Is that threshold might be crossed several times, or after passing this perfect threshold, you are just fully aware of what is exactly happening? How is that?
You are in the liminal place. When you are, you have it, you don't have it. You are in the threshold concepts are liminal. You are between the two ways of reasoning, but once you cross, and yeah.
Okay.
But there is a time where you are between both ways of reasoning. Okay,
so this is a moment when you can see the portal, but you are hesitating about walking through it.
Yes.
Okay, perfect. I have an additional question, but before I ask another question, I can see the question on the chat. Can this method be used only in STEAM, or can it also be done in economics? Do you think that this Socrative, using a Socrative and AI, might be also used in the other branches of science, like economics?
Yeah, we test it. In fact, we give a course in some universities with many disciplines, including economics, history, law, languages, and can be used at several levels, perhaps not so deeply as our research, but having in mind the expert's way of thinking, the student ways of thinking, and a problem to be solved, and that can identify the student problems, and it can be used in every single discipline. We test it.
Okay.
Yeah.
The key is to write a context with the expert way of thinking and the alternative conception of the students or the problems of the students.
The context is the prompt.
It's the prompt,
but extended, very big prompt.
Okay.
All distractions.
Yes.
Okay, understand. Going back to the beginning of your presentation, I also do have, of course, thank you for previous question from the chat. If you would like to ask more questions, just feel free. I will read them out loud. So another question from me would be, you mentioned that there are students who are just passing, they are just reproducing the knowledge. You stated that.
Yeah.
And some of them are just processing the knowledge and they want to gain more. Do you know, maybe you made some tests, what is the percentage of the students who would like to understand and develop, and what is the percentage of the students who are just trying to pass the tests? Do you have any numbers about that?
I think I don't. There is a validated test just for that, to see what kind of students you have in the classroom. I haven't used it, but in my class are 100 students, and I have 2 of deep processing. 2.
Okay.
2%.
2%.
Yeah, it's very yes.
Okay.
Yeah. If you force them to think and to reason, they try to do it. But students who naturally need to understand, I think between 2-5%, not more. The problem, I think, is the high school, because they don't used to think in high school, so they don't think in the university. So this is
they just want to pass.
They need a high mark to get into the university they want to go. So they are like trying to get good marks by reproducing. And some of our students tell me, I don't want to think. I don't want to think. Tell me how to. Tell me the process. Tell me. No, if you don't think, you don't pass. You need to think.
That's true. As a matter of fact, I saw some publications regarding that, and it appears there are scientific proofs that thinking is painful. That's probably our students are resisting so much, because this is difficult, because this is energy consuming, because our brain is consuming like 20% of our energy, despite the fact that it's only the 2% of the mass of our whole body. So 10 times more that we would expect. So probably that's the reason. That's refreshing thought. But as I understood you, because I hope I understood you correctly, but I would like to clarify it. So are you saying that if you would use this Socrative method and using AI, you can increase this number of 2% up to something a bit higher?
We hope so, because they are not used to think, and this tool will make them think. And once you understand something, it's very satisfying.
Okay, yeah, that's true. That's true. Even for the teacher.
But they don't know, because they never tried. So we hope, but we will analyze in future results.
Next year, maybe next year we can meet again.
Okay, I just wanted to tell you that would be very, very cool to have you here next year, and then we could talk about the process and how would you manage to increase this 2%. Even 4% might be a success, but maybe we can have even more. Okay. Okay, let's hope it. Let's hope it. And and I have last question, and I'm just checking the chat if someone else just asked another question. Okay. So, okay. So my last question. This is from the first slide that you had. So, what do you think? How many of those students do not want to gain the knowledge? That's probably not exactly connected with this. Primary school, because you mentioned that they are gaining this knowledge just to have some marks or to graduate for a perfect or dreamed of university. What about those students which do not want to have this knowledge? How many of those students, probably only at the primary schools, are there?
It depends on the degree, because, for example, if the degree if you get into a degree that you don't want it to get into, I want to study medicine, but I couldn't. I don't have the mark to study medicine. I'm going to economics. I'm not motivated with that. I don't want to be there. So that depends at the degree and at the university. This type of students are not included in this slide, because these are the ones that don't want. We assume that the students want to learn. So they want to learn, but they cannot, because some of them feel that they have a lot of things to do, many subjects, and like distress prevent them to understand that.
Okay. Yeah.
Okay. And we think that artificial intelligence, as is a tutor 24 hours, 7 days, will help them in that point also. And it's very motivating. My students are asking, when can we access to the tutor? When we want it. They are motivated because it's a new technology. So I'm sure they are gonna play, because it's playing. When we make experiments, we are playing and we enjoy a lot. So we think that this, and even with the ones that don't perceive the importance of understanding to pass, the tutor is gonna be asking them, why are you thinking this? Why you don't have considered this resistance? Why, or which current is, which voltage? It will be made them think.
Yes.
That's the key point.
Maybe this kind of questions are the questions that the students should make themselves, but they are not able to make these questions. So we have to provoke it.
Yeah,
And these are the questions that we do to them in tutories or in the classroom, but we can attend how many students? A few ones, not hundreds. Mm-hmm. So it's like, we hope.
That also made me think that probably the tests which were based on the conversations with the students were much better just to check if the student is understanding the subject. Probably the tests which are just written every single time, they do not check the real knowledge, or maybe not the understanding of the problems. Maybe that we should think more about going back and having some more oral exams.
Yeah.
Are those popular at your place? Because in Poland,
no, but
not at all.
But many people is thinking about them because of the use of ChatGPT doing.
Okay.
Tasks. So yeah, there is a debate now about it.
Okay, so am I understanding that correctly? So you are also thinking about going back in time and doing oral exams popular again?
We have also, with this tool, we can see how the students think.
Mm-hmm.
Not only answering to the tutor, but the questions that the student is doing to the tutor. And then we can process all this information also using artificial intelligence.
Okay,
because
so
our time is limited.
Okay.
We are thinking about substituting the oral exams with artificial intelligence. But some colleagues of us, are talking about the traditional oral exams also.
Okay. So probably when the groups are small, maybe traditional approach to the oral exams might be okay. But if you have like hundreds of students, because it happens from time to time, it's just impossible.
It's impossible to manage.
Yeah, we would have to probably, I don't know, clone ourselves to to do all those things. And you also mentioned about the stress of those students, and you present it as a reason why they are not learning, why they don't want to learn a specific tasks. Maybe that is connected with this limited time, because they have many different subjects, because they have some things to pass, or some projects to deliver, and maybe just the cortisol which is produced during that process is preventing them from really trying to learn. That's also a difficult subject. Do you think that our students are sometimes just overloaded? Because you stated that in this particular slide.
They are. We are sure they are. Because they have many exams, many tasks to deliver, and from time to time you can see their faces.
That's true.
Yeah,
they are more than sad.
Yes.
what do you think? What we can do with that? What should be our thoughts as a teachers? How to prevent this overload? Do we have any thoughts about
coordination? Coordination is crucial here between all the subjects that a student has, but it's difficult also.
Yeah, that's true. That's true. But still, it appears that AI might be very useful tool, and this Socratic method to check if really our students are understanding what is happening.
Yeah.
Okay, so my questions are depleted for now, and I can see that no one else is asking some questions. I would encourage you to fill the form if you need the certificate at the end of our Didactic Friday. And thank you, ladies, for delivering such a great speech and for answering all of those questions. We are already answering for the questions for more than half an hour. So thank you very much for your patience. And I hope to see you again next year, maybe after you finish your research.
Yeah, sure. Thank you to you.
Thank you very much.
Thank you very much. And I hope to see you soon. Thank you and bye.
Bye-bye.
Thank you. Bye.
Bye.